Okay, so before we can talk about the two uh, methods that use the time value of money, we need to talk about what time value of money means. Now, this is going to be a very simple explanation. Yes, it certainly gets a lot more detailed and more complicated than this. And again, for those of you who are going on to the university and will be doing taking upper level finance classes, you'll get into a lot more of those discussions there. So we're just going to be doing a very short, simple exercise. Now, I really hope you have your notes printed because you will need the present value tables. So I've put them in your notes. They're posted in my TCC Blackboard under chapter 11 in the lessons with the handout. So there's some on the back of your notes as well as some attached there. There's some in your book as well. So if you have the ebook or even the regular book, you'll want to pull those up and look at those tables as we go through this so that again you can really engage. You will be required to calculate present value using the tables. So that's why I want to make sure that you understand how to do that. So the basic idea of time value of money is that the value of money changes over time. Specifically, the value of a dollar changes over time. It decreases over time. And we know this. If you've taken economics and you've talked about that market basket of goods, we know that the value, the purchasing power of a dollar is declining over time. If you've ever talked with your parents or grandparents, we know that prices are steadily rising for most goods. Certainly the prices of some goods have come down over time, but for most goods, general price levels rise over time. I mean, I know my in-laws for their first house, I think they paid like $35,000 for their first house, and you can't buy a house for $35,000 now, right? So just the prices, the purchasing power of a dollar is declining over time. So the idea is that if we're going to buy some investment or invest in something that's going to last, like let's go with the B2B portal, the $60,000 in year 6 is not exactly the same as the $60,000 in year 1. They have a different purchasing power. And so we need to take that into consideration, especially for these long-term assets that are going to be, 5, 10, 15 years. That value can really decline over time. So when we calculate the present value, we need to know three things. First of all, we need to know the principal amount. The principal is the amount of money. It's either a single lump sum amount or it's an annual amount. And if it's an annual amount, we call it an annuity. And we'll talk about that more in a minute. We need to know how long this is going to happen for. What's the number of periods? For our purposes, the periods will always be years, but periods could be months, they could be weeks, they could be quarters. And then we need to know the interest rate. So the interest rate is not necessarily what the bank is paying. It's not necessarily even inflation, although that goes into it. The interest rate is what you determine you would earn on the investment. So it encompasses a lot of things. This interest rate can encompass, what other things could you do with this money? So if I didn't invest the money, I could put it in the bank and how much interest would I earn on it? Or I could buy bonds and how much interest would I earn on it, right? It would include inflation. So we know that there's inflation here. We need to build that into the interest rate. But it also includes our expectation of riskiness, okay? So if we were going to invest in something that was really, really risky, we would require a higher interest rate. We would have a higher rate of return because we would say, look, this investment's going to have to return a lot of money to get me to accept this risk. Whereas investments that are less risky, they're going to have a lower rate of return. So I always use the example of, let's say that we were trying to expand our operations and we were going to go into some different countries, okay? So we could go into Canada, or we could go into um, a country in somewhere where there's a war, Okay, well, we would obviously assign the war-torn country with the higher interest rate because that's a lot riskier than, let's say, going into Canada, where Canadians are very chill, right? That's less risky for us, so we would have a lower interest rate that we would demand for that. So again, we're going to need two tables. You're going to notice if you printed out your notes, or you're looking in your book. Now in your book there are present value tables and future value tables. We're only going to need the present value tables. You'll notice that there are two of them. There's present value of $1, which you'll also hear called present value of a single sum or present value of a lump sum. This is when the cash flow occurs one time and one time only. And then you'll see present value of an annuity. An annuity is a series of cash flows. So anytime we have a cash flow that happens every year, we're going to use the annuity. So if it's an annual cash flow, we use the annuity table. So the easy way to calculate this is you're going to find those table values are called factors. So you're going to find the factor based on the interest rate and the number of years, and then you multiply that factor by the cash flow. So let's do an example. So we're told how much would we have to invest today? In other words, what is the present value to have $13,383 in 5 years if the interest rate is 6%? So since this is a one-time only cash flow, we're going to look in the present value of the $1 table. You're going to find interest rate of 6% across the top, and you're going to find n equals 5 along the side. So go those two and find that factor. And again, I like to print it out and I like to circle it because those numbers are kind of small and it can be kind of hard to read. So your factor, when you find it, should be about 0.747. Okay, now depending on which table you might be using, you might find some tables have more decimal places, some tables have less, but it should be about 0.747. So therefore, to calculate the present value, we'll just say 13,383 times 0.747. So when we do that, we get 9,997. So what this tells me, if I invest $9,997 today in an investment that earns 6% per year, then in 5 years I would have $13,383. Now, let's look at the annuity. So for our purposes, an annuity has to be a series of equal payments, meaning it has to be the same amount every year. So your clue is when you're reading these problems, because they're all word problems, anytime it says the word annual, that it's an annual cash flow, annual net cash inflow, anything like that, annual makes you think annuity. So you're going to look at the table the same way. You just make sure that you're looking at the right table. So here we're told, assume that instead of receiving a lump sum, you're going to get $2,000 every year for 5 years. Go with that 6% interest rate. So again, we're going to look 6% across the top, 5 down, find that factor. Now you'll notice that this factor is greater than 1. It should be approximately 4.212. All of the annuity factors except for year 1 are greater than 1. Okay, there's a reason for that. I won't go into it right now, but I can explain it later if you're just really interested. So we're going to multiply that factor of 4.212 by $2,000 by our annual cash flow. So that means that if we received $2,000 every year for 5 years, well, we would have received a total of $10,000. It would be worth $8,424 today. So if someone came to you and said, hey, I can give you $8,424 today, or I'll give you $2,000 every year for 5 years, which would you prefer? If your interest rate was 6%, you'd be like, I don't care, they're exactly the same. Okay. So let's try a scenario. So here we have 3 options. Let's assume you won the lottery. And we have 3 options. You can take $1 million now. you can get $150,000 every year for the next 10 years. Or if you wait till year 10, you can get $2 million. Now, assume that your interest rate is 8%. Okay, 8%. I want you to pause the video, calculate what these three would be, and then come back and let's look at it. All right, so option one, $1 million now is $1 million. You don't have to discount that back. This is in time zero, and you notice that there's no year zero on the table. So $1 million is worth $1 million now. So this one we didn't have to do anything to. So option two, we would look up in the annuity table because it happens every year. So we would look up 8% in 10 years, and you get your factor of 6.710, multiply that by your annual cash flow amount of $150,000, and you get just over $1 million, $1,006,500. Or we could do option three. So since option three is only a one-time cash flow, we would look that up in the $1, the present value of $1 table. You look up 10 years, 8%, you get a factor of 0.463. So when you multiply 2 million by 0.463, we get $926,000. So notice that even though that is double the amount that you would get in option one, it's actually the lowest in terms of present value. So we would ideally want to take option two in this scenario. It's going to give us the most money in terms of today's dollar over time. And so again, here's just that summary of those three payout options. So now let's go to the last video, and we'll use this to calculate net present value and internal rate of return.